Okay, so in this next video, we're going to go ahead and take a look at creating a hierarchy of classes. So we're going to introduce this idea of using inheritance to create multiple classes that are all related to each other in some way. So right now, what we've got is just our shape class. Right here. And in addition to this, we've got a rectangle class, which I'm now going to place right here. Okay, so in addition to these two classes, I want to go ahead and introduce a couple more, and I also want to take this idea of inheritance and start applying it in different levels. So what we're going to go ahead and do is introduce another class that's going to end up being between the rectangle and the shape. And this extra class is going to be Polygon. So place that there. We then have our inheritance relationship, so we'll connect each of these over here. So we'll have our polygon is going to be a type of shape, so the polygon will inherit from the shape class, and then our rectangle is now going to inherit from this polygon class. Okay, so this is part of the hierarchy. In addition to this, I'm also going to introduce another class that is separate from polygon and rectangle that also inherits from shape. So over here, we'll go ahead and make one additional class, and this is going to be the circle class. Place that there. And this will also inherit from shape. Okay, so the idea here is that polygon and circle inherit from shape, rectangle inherits from polygon, and then from there we can make a few other inferences. So we can also say that rectangle, because it inherits from polygon, that rectangle also inherits from shape. So any of the code that we put into shape or polygon, any of their fields and methods, all of that is going to be inherited by rectangle. Additionally, we've got circle over here that inherits from shape, but we can make note of the fact that since we didn't establish this relationship between polygon, circle, or rectangle, we can say that there's no inheritance relationship between any of these three classes, meaning the polygon is not going to inherit from circle, circle is not going to inherit from polygon, rectangle is not going to inherit from circle, and circle is not going to inherit from rectangle. Okay. Another way that we could put that, if we want to describe this in plain English, would be to just say that polygon is not a circle is not a polygon, a rectangle is not a circle, and a circle is not a rectangle. So when we establish those kinds of relationships between them, that lets us know that there's not going to be any inheritance between them. Okay. In addition to all of this, there's one additional class that I want to go ahead and represent at the very top here. This additional class is not something that we're going to need to construct ourselves, because this is something that already exists as part of the Java API. I just want to take a moment to conceptually explain a little bit about this additional class that I want to include, which is going to be the object class. So that goes at the very top, and we're going to have shape inherit from that. And the reason that we're going to have shape inherit from this object class is because of the fact that everything inherits from this object class. So object is a very important class that is a part of our Java API. Every other class inherits from this object class. This is where we are getting certain kinds of methods. For example, the reason why it is that we can use the toString method to establish a particular string that we want to print to the console anytime that we put objects of a class into a print statement is because of the fact that the toString method actually comes from this object class. And so it has its own specialized behavior that was established because of this object class. And every time that we try to make our own custom toString method, that's actually another example of method overriding, where we are effectively overriding this toString method from the object class and making it into something more specialized for that particular class that we're using it in. Okay. Alright, so now that we've seen this hierarchy, we're going to go ahead and start trying to create this. But before we can really get into putting this all together, there are two other things that I want to establish about our current setup in our implementation. So I want to go ahead and rearrange the organization of these different programs. I'm going to end up setting it up so that all of the programs related to my custom classes, so the part of this hierarchy, I want to move all of this into its own separate package, and I'm going to take my demo and place that in a second separate package from these four classes here. Additionally, because I'm going to be doing this, I also want to take a moment to talk a little bit about access specifiers. So we've seen the public and private before, so if we come over to our code for a moment, we've seen these two access specifiers, private and public. We know that with private, this indicates that we do not want to allow other classes to have access to whatever it is that we're setting to private, whereas with public, it's effectively the opposite. We make sure that all of the other classes have access to something that is public. So for example here, we've got our length and width. We made them private, meaning that only the rectangle class can access either of these. Whereas for this constructor, we made this public, meaning that other classes can use this constructor method. So there is a bit of a catch with making these things private. So I mentioned before that both the fields and methods of shape, rectangle is going to inherit those. So far we've seen instances where we were, say for example with the super method, needing to call that. So that indicates one sort of example of inheritance. In addition to this, we also actually used methods like getApathem, as well as setApathem previously. These are methods that come from the shape class, but we were using them on rectangle objects. So to that degree, we've indicated that there is this idea of inheritance going on. So what about the actual field? What about the apathem itself? Well, for the length and width, I've been using those with this.length and this.width throughout the code for my rectangle. So what if I want to go ahead and access the apathem as well? So let's say that right here when I'm getting the area for my rectangle, maybe I want to make use out of that apathem in some way. So maybe instead of using just the width, since I am representing this as my height, maybe I want to go ahead and use that apathem. But since the apathem is the width divided by 2, just to go ahead and make sure that everything still matches up properly, we'll just go ahead and multiply it by 2. So I want to go ahead and just rewrite the getArea method to be able to demonstrate using the length and the apathem. So we're going to use two different fields to do it. So we'll go ahead and set that up, and we'll come over here and we'll compile this. So we'll go find our setup right here with shape.java, rectangle.java, and our rectangle demo.java. We'll go ahead and compile that. But we run into a bit of an issue, which is that our apathem has private access in shape. So even though technically our rectangle class is inheriting this field, the field itself, where we declared it, was inside of the shape class, and within that declaration we made it private, meaning that only the shape class can actually directly access it. So if I wanted to use that in here, I would have to actually go get it. So to get it, we'll just use the this keyword and getApathem. So we'll just go ahead and say this.getApathem. That way then we can just go ahead and go get the apathem from there. So we're just going to go ahead and call a public method that our rectangle class does have direct access to, and we're going to use that to go access the private data that is in shape. So we'll go ahead and compile this again. And now we can compile it without any errors. And if we wanted to, we could also go ahead and run it. So let's go ahead and run our rectangle demo, and then we can see the area the rectangle is, and we still get the same value as before because the math still comes out the same. Okay, but obviously you generally don't really want to have to do it this way. It would probably be ideal if we could just directly access the fields from shape. So what we can go ahead and do is actually modify this so that instead of being private, we can change this to a different access specifier. And this other access specifier that we can use is what is known as protected. And with protected, what this is going to do is restrict access to something that is protected, say like this field apathem, it's going to restrict access to only these subclasses and any classes that are in the same package. Okay? So in this case, because rectangle is a subclass of shape, now rectangle can directly access the apothem. So instead of saying this.getApothem, I can just do this.apothem to access it. So we'll come over here and we'll compile it. And now we can still compile it, even though we're directly accessing a field apothem that is located in a different class. Okay. And then of course if we run this, we'll see that we still get the same output as before. But as I just mentioned, in addition to subclasses, there's also the fact that now the apothem can be accessed by other classes in the same package, say like our rectangle demo, for example. So that means that if I wanted to, I could come over here and say something like system.out.println and say, I don't know, the apothem of the rectangle is plus rect.apothem. So now instead of using the getApothem method like I did up here, I'm just going to go ahead and access that field directly. We'll save this. Let's go ahead and clear, compile it. Compiles without any errors. And if we run it, we now have access to the apothem directly, and we're printing it out in this very last line. So at this point now, because of the fact that we're able to access it in a rectangle demo, because of this, we are now violating that rule of data hiding. So what we need to go ahead and do is modify the structure, the overall organization of our code, so that this rectangle demo is no longer in the same package as rectangle and shape, so that we can continue to use protected while also making sure that we still adhere to proper data hiding. So this is the part where we're going to get into introducing separate packages. And essentially what this means when I talk about separate packages, all we're really going to be doing is just moving code into different folders. So we're going to move these files into separate folders. So we're going to go ahead and make a new folder. So this first one is going to be the one for the shape. So this is going to end up being the one that will inevitably hold all 4 of these classes. So we'll go ahead and open that up, and inside of there we're going to move our rectangle and our shape. So I'm just going to go ahead and select both of those. I'm going to go ahead and cut them and paste them into here. If you're doing this from an IDE like NetBeans, that process might be a little bit more convoluted, but essentially you want to make sure that you've got rectangle and shape located in a single package called shape. And then once you've got that set up, we're going to go ahead and take our rectangle demo. I'm going to make another package, so another folder. This one I'm going to call main. Okay, and inside of this main, we're going to take our rectangle demo, cut that, and we're going to paste that right there. Okay, so the end result now is that I have 2 separate folders, or 2 separate packages, main and shape. Main now holds the rectangle demo code, and shape holds the rectangle and shape code. In addition to this, I need to also go ahead and start modifying a couple of things within the code for each of these files. And whenever I go about trying to compile and run this, the way that I'm going to be doing that will also be a little bit different now. So to start off with, we want to make sure that for our rectangle demo that we are specifying the package that it's going to come from. So I'm going to use a package statement and then the name of the package. So I'm going to say that my package is main, since that's the name of the folder that it's inside of. Over here, for my rectangle and my shape, these are going to be located in this shape folder or shape package. So we'll do the same thing here. And we'll do the same thing, over here. Okay. And then in addition to this, I also need to include something else in my rectangle demo. So because of the fact that my code is now located in a totally separate package, I can no longer directly access them without specifying import statements. So it's a lot like when we're dealing with all of the classes that come from our Java API. So all of those classes come from that library for our Java API, and they're in completely distinct packages from the code that you are currently writing. And that's why it is that you have to use those import statements. So we're going to go ahead and do the same thing here. So I'm going to say import, and I need to import 2 things. And both of these are going to come from this shape package. So I'm going to say shape.shape, and I'm going to say shape.rectangle. Okay. And of course, I'm not going to be using the Java at the very beginning of it because these are not coming from the Java API. They're coming just from this additional package that we created ourselves. So it's just going to be shape.shape and shape.rectangle. So we'll go ahead and save this code like it is. And then coming over here, go ahead and clear this. So when I go to compile this, since I'm still in Java projects, I need to start specifying that I need to compile the code that is located in these folders. For this part where I'm going to compile it, the way that I'm going to be doing that is with these backslashes. So kind of like whenever we need to specify a path to a particular location. So this much looks, I would say, probably pretty familiar to most people. So we're going to end up compiling our rectangle. Let's start with the shape. So we'll compile our shape, our rectangle, and then for our demo, it's going to come from main. So we'll do main and then rectangle demo. Okay. So in this way, we can go ahead and compile each of these. And now, because we're doing this, we see that the apthem has protected access in shape. So this line that I included before, where I was trying to directly access the apthem, no longer works. So this is a pretty good sign. So we'll go ahead and remove that line. We'll save that. We will try to compile this again. And now we can compile it without any errors. So it looks like we're good to go. So then we'll go ahead and run it. And this is the part that's going to be a little bit more distinct. So now, whenever I try to run my rectangle demo, I also need to specify the package or the folder that this is located inside of. So I'm going to say main.rectangle demo. So it's going to use pretty much the same notation as what we use for our import statements. So we use this dot notation to specify a particular package that a class comes from. We're going to do pretty much the same thing here. So we'll go ahead and run that, and now we can see all of our code printing out to the console. Okay. All right. So in addition to all of that, now we're also going to go ahead and create two other classes in our shape package. So we'll go ahead and say new file. Well, the first one we'll go ahead and do is our circle.java. So for this one, we're going to say that this is coming from the shape package. So we'll have our package shape. And we'll have our public class circle. And for our circle, this one will have just a single field. So we'll say private double radius. And then we can go ahead and use, in this case, I'll keep the code for this one a bit more brief. We'll focus just on a constructor and a getArea method. And if you want to, you can also go ahead and make a getter and a setter specifically for the radius. So we're going to have our public circle. This is going to take a radius. And then we'll say this dot radius is equal to that radius that we passed in. And then right here, we're going to say public double get area. And for this one, we don't need to pass anything in. Instead, we just want to return the value of the radius squared times pi. So to get the radius squared, we'll just say this dot radius times this dot radius. And then to get the value of pi, we're going to get it from the math library. So we'll do math dot and then the constant pi. So this will grab the constant pi from the math class that is a part of our Java API. Okay. All right, and then the other thing we're going to go ahead and create is, we've already got our shape, so we're going to go ahead and create our polygon. And there's a little bit of a catch with making this polygon, which is that all of this code that I've been using for shape, where I've been dealing with this apthem, well, this is actually something that's more unique for a polygon. For a general shape, they don't really have an apthem, primarily because of the fact that you can have things like a circle, and a circle doesn't have an apthem. So what I'm going to go ahead and do is just take all this code that we have right here. I'm just going to go ahead and cut that, and I'm going to move that over to this polygon. So we're going to have our package shape, our public class polygon, and I'm going to paste all that code in right there, and now we've got all that set up. Additionally, we can go ahead and modify a couple of different things. So we need to change our constructor to say that it's polygon. we'll go ahead and change this and say that we're in the polygons constructor whenever we get to this part of the code. And then coming over here, we've got our public class shape. And for this one, what I want to go ahead and do is not actually specify any particular field, because of the fact that when it comes to a shape in a very general sense, it's very difficult to determine precisely what dimensions it might have. So it's best to just go ahead and disregard that. So instead, what I'm going to go ahead and do is just create one simple thing, which is just going to be a constructor for it. And this constructor is not going to take any arguments. So because of that, whenever we try to use this later, say like we want to construct objects using any of these other constructors for a rectangle, circle, or polygon, because this doesn't have any arguments in it, Java won't necessarily interpret it any differently from, say, the default constructor, which also doesn't take any arguments. So in this way, we are freed up from having to explicitly call the superconstructor. The implicit call to the superconstructor will effectively call this noargs constructor. But of course, we're going to include it anyway, just for the sake of demonstrating it. So we're going to go and include a single print statement right here in the shape. We'll just say this is the shapes constructor. Go ahead and save that. And then for our circle, we're going to go ahead and introduce one for this as well. So we'll go ahead and say print statement right here. Say this is the circles constructor. And then we've still got the rectangles and the polygons. Okay. Let's actually make it match with these. So I'm going to just grab this little bit. So you are in the okay. So we'll just go ahead and save all of our code like this. The other thing I want to go ahead and do is also make sure that we have a call to super right here with nothing passed in. Make sure that we're explicitly calling it so we can actually see that call. Do the same thing right here. And so this one is going to end up calling shape. So we'll go ahead and make sure that our polygon extends shape. And then our circle, same thing, extends shape. Okay, so this should cover everything. I don't think I've missed anything. Coming back over to our rectangle demo, this is going to start getting a little bit more complicated. It's not necessarily just a rectangle demo anymore. There's a couple of other things that we're testing out. But we're going to go ahead and include a couple of additional import statements. So we're going to import shape.polygon. Oops. And we're also going to go ahead and import shape.circle. Okay. All right. So now that we've got all of that, what I want to go ahead and do is just comment out all of this code right here. And the main thing that I want to focus on is just a couple of different calls to the different constructors. So let's see. Our shape no longer takes an argument. So when we do that here, we will remove this. I'm going to go ahead and take this, place this right here. We will then also go ahead and call a polygon. So let's go ahead and make a polygon object. We'll call it just poly. This is equal to a new polygon. This is where we can specify our apothegms. Let's say 6. We then have a rectangle, and then I'll also go ahead and make a circle. We'll call it just cir. This is equal to a new circle. This is expecting a radius. So let's say for the radius for this one, we make it something like 10.3. Go ahead and save that. And so now what I need to go ahead and do is compile all 5 of these. So we'll come over here. We'll see if I've got any mistakes, and then we'll kind of explain a little bit more about precisely everything that's going on. So we've got the 3 already, and then I just need to go ahead and add in the polygon from the shape package, and then the circle. And it seems like I may have accidentally added semicolon. Did I do that on both? Yep. Go ahead and try this once more. Oh, yeah, so this is for for the rectangle, this should actually extend our polygon instead now. So we're going to make sure that this is extending the correct thing. We'll clear this, try once more, and now we got it. Okay. So now that we've got that, I'll also go ahead and run it once. And now we can see all of the different print statements. Oh, this is for a different class that we don't really need anymore. We want main.rectangle demo. There we go. Okay. So now we can see the different constructors printing out, and now I can go back through the code a little bit more to explain everything that's going on. So starting from the very top, we've got our shape. So this is part of the shape package, explained right here. We've got our class header, and then the only thing that I've included for this is just going to be a constructor, so that I can go ahead and print out this statement, you're in the shapes constructor, so we can see whenever we access it through the console. Next we have our polygon. So the polygon is going to extend the shape. We can see that right here. Polygon is going to inherit from the shape class. So we're going to go ahead and use the extends keyword. We've still got all of that code that we saw before. We've also specified our apothem to be protected. So only the rectangle, as well as say the circle and shape, will have access to that now. Ideally, because of the way the circle and shape are designed, we don't really have any intention of ever using the apothem, whereas with the rectangle demo, there is the possibility of wanting to get or set the apothem. We just want to make sure that the user can't do that directly now. Okay. So we got our protected field, we've got our public methods. So we've seen all these methods before when we used them in shape for our previous version of all this code. Coming over to the circle, this is also going to extend shape. So you can see circle over here extends the shape class. We've got a private field for this. Because of the fact that shape or circle doesn't have any subclasses, we don't need to make radius protected. So instead we'll just go ahead and set it to private. Okay. So the key distinction here between protected and private is that if we have a field that might need to be accessed by the subclass, then we should consider making it protected. But if we're dealing with a class that has no subclasses, we should just always make its fields private. Okay, so then we've got our constructor for circle, we've got the getArea method, and then for rectangle, we've got our two private fields because it has no subclasses. We've then got our constructor, and then our setters, getters, and our getArea method here at the end. So the important thing to take a look at right now, on the very first line in the main method of our rectangle demo, we have a call to the shape constructor. So that's where this first instance you're in the shapes constructor comes in. Next we have a call to polygons constructor. So if we come over to Polygon, we see this call to super. So I've explicitly written this out so we can see where this is occurring. So that's going to force us to go into the shape constructor, and that's where we see the second instance of you're in the shapes constructor, and then followed by that we've got you're in the polygons constructor. So these two lines right here are in reference to that. Next we have the rectangle. So coming back to our demo, we've got this call to the rectangles constructor. So if you come over here, we have a call to super. So that requires going into the polygon that rectangle extends. Again, another call to super, so we move into shape, which polygon extends. And so because of all that, we get these three statements here. So we're going to say you're in the shapes constructor, back over to the polygon, you're in the polygons constructor, over to the rectangle, you're in the rectangles constructor. And then finally, we've got this call to our circle constructor. So if we come over to circle, we again have this explicit call with super over to the shape constructor, since our circle extends shape. And so we're going to go ahead and print out these last two lines. You're in the shapes constructor, and then right here, you're in the circles constructor. Okay. So at this point, I've kind of gone through this in a way that is, I would say, fairly quick. So it would probably be in your best interest to take a moment to kind of review these 5 classes and this organization or this ordering of the class hierarchy, so this hierarchy that we created right here, to make sure that you fully understand the relationship between each of the different classes that we have here, so that you have a good grasp of this idea of inheritance when it's being applied to more than just two classes. So in this case, when we're dealing with 4 different classes, with some of them inheriting from one another. Okay. So this is going to wrap up everything for this hierarchy of classes. Going into the next video, I want to start taking a look at a more abstract concept related to inheritance, which is this concept of polymorphism.